Okay, hello class. Today is the 20th day of June 2017. Welcome you to this seminar which will be on multiple regression analysis. Can we be quiet a little bit? Let's be quiet. The seminar has started. We are going to have a couple of presentations today, and we will begin with that of Johnson Famuyide. I'm sure it's set for the presentation. Are you?
Yes, I will.
I'm talking about Johnson. Johnson, are you set for the presentation?
I am set, sir.
Okay, that's fine. Now let us look out for Johnson's presentation. What is the timeline that you have on the chat window for your presentation?
Let me check it out, sir.
That for mine is 1:39 p.m.
PM.
1:39 p.m. Please, Johnson, you have the
Sir,
floor. Please make your presentation.
good evening, class. Good evening, class. Good evening, Mr. Johnson.
Yeah, good evening, man. Yes.
I trust every one of us had a very good day today.
Yes, thank you.
Before me today is multiple regression.
You know, you have 8 minutes, 8 minutes, 8 minutes for presentation, and we'll take 2 minutes for discussion. Go ahead.
All right. Multiple regression. So let's go straight to slide 3, where I did a bit of introduction, and also I put there the scholar that first of all mentioned multiple progression, person of Pearson in 1908. I said multiple regression rather, is an extension to linear regression. And then I feel of a better way to justify multiple regression is to compare and contrast it with simple regression. And that is on slide 4.
Go ahead, Johnson.
All right, sir. Yes, I said way to justify multiple regression than to see compared to simple and multiple regression. And the simple truth about it is that simple regression is talking about one. Simple regression is talking about one dependent variable, but so many independent variables. Unlike dependent variable, and we can go to the slide and you see that I have differentiated the two from one another. One regression multiple regression talks about one regression coefficient for each independent variable, and then the R squared, which is very, very important when we are making and when we are doing our report. Let's move to slide 5 when to use multiple regression.
Okay.
When do we use multiple regression? We use multiple regression. We have one dependent variable and so many independent variables. So let's go to slide 6. In slide 6, mention the methods of multiple regression. The beauty of this is this, that you are using SPSS to do your analysis. You have it up there that all you don't need to cram anything. You don't need to cram direct or simple regression, forward regression, backward regression, or stepwise regression. You don't need to cram anything. Once you get SPSS, you will be able to select whichever one you want to use. Let's move to slide 8. On slide 8, we saw the multiple regression formula. Y the predictor, response dependent variable, observation, or Y variable. And we saw the error. Slide 9, mathematical model. Then slide 10 talks about the assumption of don't mind me, I think them mathematical model.
Yeah.
I've told us that we don't need to have one
Yeah.
So I'm taking that as an attitude.
Yeah. Your voice is jerky. I guess it's your connectivity. Your voice is not flowing through very well.
Continuous or categorical
Yeah.
dependence of residuals, linearity, homogeneity, no correlation between not related regression model, normal, no linearity, no significant outliers. 11 is a real of everything. We want to see how multiple regression in SPSS. And the example we are going for us, conduct multiple regression data for this way 11. Example, and we have a question we want to solve there. Conduct multiple regression on the data to predict achievement score based on group, sex, socio-economic status, and school location. Which one is dependent variable and which ones are the independent variable? The dependent
Variables. My friend, it's more than one, so variables.
Variables. The dependent variable here.
Yes.
Independent variables. Sex, social economy.
Yeah, it's jerky again.
57 participants were chosen to do this. Women set first set of 57, and this we will be seeing the report in a short while.
Yeah, you have about 2 more minutes. Just go straight to that report.
Let's move to slide. It says we have 5 variables, and you will see them listed. Let's go to slide 13. We see how we built them and created all those variables in SPSS. On slide, we look at how we do the real thing on SPSS.
Good.
So we go to the main menu, click analyze regression, click on regression, then on linear. You can see on linear. You can see that as is shown on the slide.
Very good.
And then you will be given the one, and the next thing that you will have is it will be this that we have on slide 15. And on this slide 15, you will see that the dependence box is empty, and the independence box also is empty. And then we'll go to slide 16, where we transfer everything to where they are supposed to be. You see that shown in SPSS. Now in slide 16, we go to important data for the report. There is no analysis.
Yeah. Yep. Yeah, the line is jerky again. The line is jerky again.
And you will see I highlighted things that were the R and the R and the adjusted R square. And on the ANOVA also, the degree of freedom, the level of significance, that it is 0.00, which is lesser than 0.0005.
Yeah.
See the conclusion. Slide 8. It's not the estimated model coefficient. Predicted achievement.
Very good.
These independent variables, how they contribute to predict achievement. Let's go to slide 19, where and the conclusion is this.
Yes.
Achievement from next location. Who statistically significantly predicted achievement with this F, and we figured that our F is at 6.57. And what we saw that it is only the added statistics. All our is at 0.05. last slide is my reference.
Yeah, okay. All right. Let us applaud him. Let us applaud Johnson. Yeah, although we had some challenge with your presentation, not necessarily your fault because it's some connectivity thing. So let's have questions for him. Francis.
Question is on slide 7.
Yes.
When you talk about backward regression, can you please really mean, sir?
Okay. Is it the question? Is it to me or to the presenter, or to both of us? Okay. Now, Helen, your question.
Thanks, sir. I just want him to briefly explain outlier, and also on slide 11. I'm not too comfortable with example with SPSS.
Okay. What are you not comfortable with? Yes, what are you not comfortable with?
Example with SPSS.
Okay.
To look at the topic. He's trying to look at the research title that we can use for the multiple regression. And also he's trying to explain something on the third dot. The researcher goal is to be able to predict achievement and the rest. I think that's why I said I'm not comfortable with example.
Okay.
Yes.
Wonderful, thank you. Madam Mary Olayonju, our mommy.
Yes,
Mommy
sir.
one. Yes, your
Yes,
question?
sir. Yes, sir. My question is on slide 18.
Slide 18. Yes.
Yes, sir.
Go ahead. Yes.
I would like to establish the set of independent people. But then we have two sets.
You have what?
I'd like you to explain.
Okay. There's some noise coming from. Larry, ask your question. Okay, fine. So, Johnson, you now have the floor to respond to the questions raised.
Alright, someone asked about backward regression.
Yes.
Method. And based from the slide, you can see that I kind of explain it there. Start with them all. That means it is just like the examples that I've shown before. That once you put them in, and you are trying to now adjust the R square, you are trying to look at the contribution. The R square.
Yes.
It talks about the contribution of each of those variables on predict the dependent variable.
Go ahead.
It's like you are kind of manipulating them. So that is the backward regression method.
Okay, let me join you in explaining backward regression method. You recall that when you have all your predictors, you can throw them all once into the equation. That's the enter method. I think in class I demonstrated it by bringing in people, and I started to take you out one by one. Now the stepwise regression. Can you recall that I did that in class?
Yes, sir. Yes, sir.
So enter method is all the variables bam together into the equation. The stepwise is now you bring the first variable, maybe gender or sex or whatever you want to call it, you put it into the equation. If it doesn't, in quotes now, weigh well, throw it, the thing is thrown out, it goes on to the next one, it goes to the next one, so it's stepwise like that. Now, the backward is the reverse, whereby you put in them in and start removing them one by one. So enter is together, stepwise is one by one to the end, backward is all, and then start removing them after you will have entered them. Is that a little bit clearer?
Yes,
sir.
Wonderful. So, Johnson, conclude the answering of the questions raised.
and someone talked about outliers.
Yes.
We know statistically that outliers are those people that they are those data that really moved away from the model fit. They are
Yes.
farther away from every other data. That means their own variation is their variance is far away from every other variance. Then
Okay. Let me
like,
also give a little bit more explanation there. I think it was who asked. Was it Helen who asked that question? Okay.
It
Whoever.
is Helen, sir.
Helen. Okay. Fine. Now you look at this. Look at this. Look at these figures. Look at these scores. Maybe scores for achievement test, like 8, like 9, 9, 7, 6, and then 32. So you can see that 32 comes way out. It's an outlier, and it distorts your variance. So the outlier are the scores that are at the fringes, very far from the crowd. Is that clear?
Yes,
yes, sir.
Yeah. So many statistics are very sensitive to the outliers. And if you know that you have those outliers, it's possible for you to statistically partial them out, so you can retain the ones that are that are compliant, so to speak. So now, answer the last question now, Johnson, before we move on to Helen.
Yeah. The last question on slide 18.
Yes.
He asked that I'm supposed to explain how those variables contributed to the prediction of achievement. And if you see, like I'll just explain that of group. We said it is only group that significantly contributed. And you see what this is saying is this, that 0.71, that if we make every other thing to be stable, and as in to be, like if you say 0.03 times 0, and every other thing is out to make them to be stable, then there's
Yeah.
0.71 that the contribution will be. The first contribution is going to give, that is like 0.71 to the predicted achievements.
Okay, that's
Have
good.
I been able to explain that?
Yeah, I think you did well. You did well. So we thank you again, Johnson Famuide, for your presentation on multiple regression. To our class seminar, and just a minute, we've got to welcome to our class seminar. And today we shall be continuing our seminar on multiple regression analysis. We had the first one presented by Johnson Famuide. Today we're going to have Dr. Helen, we're going to have, let's see, Madam Oeduni, if she's set, and then Kennedy Akudo. So let's kick off with Helen. Helen, you have the floor. Helen, you have the floor.
Good evening, class.
Good
Good
evening.
evening, class.
Good evening.
Good evening,
Welcome.
sir. Good evening to our distinguished Professor P. Okebukola. I am Hayenowa Elin Iliola from Lagos State University, Ojo, Department of Science and Technology Education.
No, you don't need all of that
I'm
because Helen, hold on. You don't need all of that. We know you. We know the department. Just go on to make your presentation. You are losing precious time. All this one about departments, Lagos State University. The whole thing is about Lagos State University. The whole seminar is in Department of Science and Technology Education. So don't waste time. Yeah, go ahead.
I'm presenting multiple regression. Let's go to slide 2. Multiple regression is a statistical tool used for prediction. It's an extension of simple linear regression. It is used when we have a predicted variable, that is the dependent variable, and more than one predictor, that is the independent variable. Let's go to slide 3. For example, we could use multiple regression to understand whether WAEC result of senior secondary school students can be predicted reading habits, peer influence, class attendance, participation in extramural classes, and gender. Class 4, brief history of multiple regression. Johann Carl Friedrich Gauss. He was a German mathematician with his colleague André-Marie Legendre, a French mathematician. They both used regression to observe the orbit body of the sun. Later, Gaussian Sir Francis Newton, an English scientist, and also is also a mathematician. He was the one that promoted regression towards the mean. And with his colleague,
You are spending too much time. You are spending too much time on the historical, and you didn't tell us to advance to the next slide. Please move on very quickly. You are spending too much time on irrelevancies, not the necessary irrelevancies, but things that you just mention in 1 or 2 seconds.
all right, let's go to slide 6. Adoption of multiple regression. We have normality of population, random selection, multicollinearity. All of these has been discussed by my colleagues. Because they are all parametric statistics, they all have the same assumption. On my slide 5, I have mathematical model of multiple regression. This mathematical model is for linear regression. The A
Yes, carry on.
is the contribution of the predictor, and the Y is the predictor, which is the dependent variable, while the X is the predictor, which is the independent variable. On my slide 8, when to use multiple regression. Number 1, when you collect data for prediction, when you are interested in relative contribution of a set of independent variables to one independent variable, when you want to forecast, and also you have to look at your sample size from 50 and above. On slide 9, I have example of a study.
Yeah, go ahead. Yes, certainly we are waiting. Okay, let's get Kennedy to make his presentation on multiple regression. So, Kennedy, you have the floor.
With introduction on slide 2, there we have the term multiple regression as a term being first used by Francis Galton in the early 19th century. The term is an offshoot of the linear regression, which came as a result of trying to predict a particular dependent variable by means of several independent variables. So let's quickly go on to slide 3. So what about multiple regression?
Yeah.
It is used for prediction. It predicts the extent at which the value of a dependent variable can be determined as a function of 2 or more independent variables in the presence of random error. Let's quickly move on to slide 4.
Yes, we're there.
There are some statistical assumptions that could be made before one can multiple regression. So 4 of these assumptions are normality of population, homogeneity of variance, randomization of samples, and multicollinearity of variance. So if these are met, then one can go ahead to use multiple regression. Let's move on to slide 5.
Yeah.
Example of a model with 11 independent variable is what we can see there, and then 1 dependent variable t. So we want to move on to the slide 6.
Very good.
When to adopt multiple regression, we have two instances here when several predictor variables act to produce effects on a singular predicted, and then it is used for forecasting future events or predicting an intended outcome. We'll move on to slide 7, sir.
Yes, we're there.
Are you there in slide 7? We have a typical study on multiple regression. The impact of some socio-economic academic factors on the final grade of a postgraduate student in Lagos State University.
Like yourself? Okay. Okay.
Want to move on to slide 8.
Yes.
Slide 8. Purpose of the study. Purpose number 1, the objective is to predict factors with high or low impact on the final grade of a PhD student at the end of the program using the student score in statistics tests and some social, economic, academic factors for internal validity. And then it is used to infer or forecast the outcome of all the postgraduate students in Lagos State and beyond. And that is when we're talking about the external validity. Let's move on to slide 9.
Yes, go ahead. I'm just sending a message
enough
to
to capture all the variables. This will the socio-economic academic factors, which includes all of these 11 independent variables of the students, produce high grades at the end of their postgraduate program at LASU. This is a typical research question that translated into the next hypothesis on slide 10.
Okay, that's fine. Now, Kennedy, are you there? Kennedy, can you hear me?
Yes, sir.
Yeah, I'm so excited about this, and I want to see whether I can predict your performance using all these variables. But you see, the one of height is interesting. The height. So, who is the tallest in class? Who is the tallest in our class?
Yes.
Who is the tallest person in our class?
I think Yusuf looks tall.
Yeah, even you are tall. So let us see how the
Dr. Yusuf.
Okay, let's see how the variable of height, will come out in this your hypothetical study. Very interesting. I'm so delighted about today's class because hold on. Because we have quite a lot of of members that are in this seminar, quite a lot, and it's quite exciting. So please carry on, Kennedy.
So this question is translated into the next null hypothesis on slide 10. Are you on slide 10, sir?
Yes, go ahead. Yes, we're there.
Okay, slide 10. The social, economic, academic factors, which includes gender, home location, parental age, Skype presentation, class attendance, Skype attendance, siblings, lateness, height, assignment, and academic ability of the students will not produce high grade at the end of the postgraduate program at LASU. So that is a conjectural answer to that question. So we move on to slide 11, sir.
Yeah, go ahead. I'm just replying Shaibu now.
So the variables have been highlighted already in the hypothesis and research question. So these are the key variables. The 11 independent variables are there, and then only one dependent variable.
Yeah.
Which is the score in statistics text. We want to move on to slide 12. 3 steps one can take to arrive at the results in multiple regression.
Yes.
Copy the data from Word or Microsoft Excel and paste in SPSS.
Good.
Then label the variables.
Yes.
Go to analyze.
Yes.
Regression linear. Then move the dependent to the right place. independent of the location, enter, method, continue, and you have your results.
Good.
So the following steps are shown on slide 13.
Sure.
So we have a sample of it there. That is showing the first 3 steps. So
Yes.
when we move on to the next slide,
Yes.
slide 14. Are we there on slide 14?
Yes, we have.
Yes,
We have
we
the
are
variables entered. Yes.
Entered variable. Yeah. The 11 variables that are entered as in the none was removed. It's showing us all the variables. On slide 15, let's move on to slide 15.
Good, we're
Are
there.
you there, sir?
Yes, we're there.
Yeah. So we have the ANOVA result, and of course the beta weights, which we're going to use to draw our regression model. Now let's move on to the next one. On slide 16,
Yes.
we have the normal probability plot.
Yeah.
That shows that all the variables are homogeneous, that they are not really much dispersed. So we'll move on to the next slide, 17. The findings of the study. 3 key findings can be reported from this study. That the null hypothesis was not rejected. This is because the F value, the ANOVA value equals 3.06 and E is greater than 0.05. This shows that the model is insignificantly suitable for the prediction of the student's final grade.
I will imagine. Sorry, Kennedy. I will imagine. I will imagine so, because the height, if it is height matter, and if it's height Skype matter, then it's anyway. Go on. That's by way of a joke. Go ahead. Go ahead, Kennedy.
All right. So the arrow value shows that the model has taken care of the prediction of the student final grade. But that notwithstanding, for the fact that the adjusted arrow square is only 54.4% of all the variables is explaining the final grade. So therefore, the model is not, because only 54 of them is explaining the. So we want to move on to slide 18.
Yes.
So from that beta weight, we arrive at this regression model, this model, final model.
Yeah.
Showing all the beta weights on each of these independent variables. So here, y is a predicted variable, and x1 to x11 are the predicted variables.
Correct.
So we move on to slide 19.
Yes.
Conclusively, there was low impact of gender, home location, parental age, Skype presentation, number of siblings, lateness to school, and students' height, which shows that gender is not.
Yeah, and all of that. Just go on. All of these ones are not. Yes.
Then there is a moderate impact of class attention, which means that if one does not pay attention in class, the person is likely not to perform very well. And there is a high impact of Skype attendance,
Of course.
of assignments,
Yes.
and academic ability, which means that if one does not even have opportunity to present as Skype, but attend classes as Skype,
Yes.
one will perform very well at the end of the program. So
Wonderful.
the next model is appreciating all of us for our patience and our endurance for Dr. Kennedy to present his.
This is wonderful, Kennedy. I actually give you thumbs up. You know, thumbs up is something that you praise, and thumbs down is something that is not so good. You have done so very well, Kennedy. At long last, I enjoyed the model that you used, and it is so very wonderful. Well done. Yeah. So yeah, no, it's quite nice. And we have, like I said, a very full class today. I'm going to take the screenshot of our class today and email to you, and you'll see how full the class is. Now, we're going to ask Kennedy questions, and the rule of the class is that you don't say you have no questions to ask. Everybody in this class today must have to ask questions. So, and when I call you, I will expect that you respond very quickly. I'm going to start with Francis. John Famuide, you stand by. Francis, your question. Okay, Famuide.
Slide 17.
Famuide, slide
On
17,
slide
yes.
17,
Yes.
I'm with you, sir. On slide 17, I want you to explain what you mean by, though the add value shows that the model has taken care of 90% of the prediction of the student final. The add value. What does it mean?
Okay.
Okay, no. Kennedy, you don't answer yet. You are going to answer. Just make note of each question, and then you answer later. Aribi, Dr. Lanre,
Yes, sir.
Madam Moraka,
Yes, sir.
stand
My
by.
question is on
Yes.
slide 6.
Slide 6, yes.
My question is on slide 6.
Good.
Well, I always have the belief that a multiple regression
Go ahead.
means that you predictors, like 3 or 4 factors. They are single regression. So I always believe that regression for one predictor to get the predicted. While when you have different predictors, that's what we call multiple regression. So please, you should explain that, sir.
Okay, that's fine. So note that. Madam Omoraka Faith, Dr. Omoraka Faith. Okay.
My question is
Now,
like
Doctor, just hold on. Let me tell you how we're going to go so that you'll be all ready. After Moraka Faith, we're going to take on Dr. Oyeduni. Mary just joined us. You may wish to ask a question, followed by Gbileyi. So, Moraka Faith, please take the floor.
my question is on slide 3. I'm
Yes.
seeing something like presence of random error. Please, can you throw more light on that? Slide 3.
Oh, yeah. I saw that too. Okay, Madam Oyeduni.
Okay.
Mary Adaje, if you are there.
Yes,
You
sir.
are just joining us. Do you have a question? Maybe not. Okay. Gbileyi.
Oh, my teacher,
Yes, sir.
okay. Mo wà ní kíláàsì à ń ṣe Skype lecture, but tó bá
My
ti dé kò sí
question is
problem.
on slide
Iroko, we don't do that in this class. Iroko.
Tó bá ti dé kò sí problem.
So you can hear Iroko disturbing us.
Yes, my question is on slide 17.
Slide 17.
Predicted variables. Yes. The predicted variables. You have x1 to x11, but on the table there you have up to 12. Can you please explain the last value there?
Okay.
8.83 without any subscript.
Okay. All right. Very easy to answer, though. Oluwatoba Fakunle, followed by Brian. Okay, followed by Mary. Dr. Mary.
Yes,
Dr. Mary Olayanju.
I want to ask
No, that's gone. We have gone past you now. Dr. Mary Olayanju.
Kennedy.
Yes, go ahead. Dr. Mary Olayanju.
Dr. Kennedy.
My question is from slide 16.
Slide 16.
I would like him to buttress or to explain more on the second and the third point.
Yes, these two. Yes. Okay, the R value and the adjusted R squared, especially. Okay, that's fine. Stephen, Madam Fumilayo.
Yes, sir.
Yes.
Dr. Kennedy.
No, I passed you. I passed you.
Sir.
No, Shino, I passed you. I passed you.
Kennedy.
Shino, I've passed you. Fumilayo. I know, Doctor. I know. Okay, they are all not set. Back to Kennedy. Kennedy, can you please answer the questions that have been posed to you? Kennedy, I know it will take you 1 hour again to start talking.
It's quite unfortunate that I didn't have the writing material. I want to quickly respond to Dr. Johnson's question about
Yeah.
the arrow value recorded by Dr. Mora. So the arrow value shows that the model has been able to
Yes, to what?
90% of the student panel have been explained by the model. Only 10% has not been taken care of. But that notwithstanding, it is the arrow squared value, adjusted arrow squared.
Yeah, that's it. The adjusted arrow
Look
squared.
at the adjusted arrow squared. It shows that only 54. All the variables that are in question, that is the independent variables, are explaining the final grade.
Yeah.
Did you get it, sir?
Yes, go ahead.
There are some variables. There are some variables in the model. There are some variables in the model which are about 46% of them are not taking care, are not making any prediction about the student's final grade. So that is why the model is not fit enough.
Yeah, that's it.
46% is so much for us to ignore. If it is something of, let's say, 17, 20%, we can ignore and say the model is good.
You are
if
correct.
About 80% is explaining the model, then it's very good.
Good.
So is that taken?
That's good answer. That's good answer, Kennedy.
Yes.
That's good answer. Okay.
Dr. Famwede, are you okay with that?
Yeah, it's okay. It's okay. Yeah.
Are you okay with that?
He has answered you. Well, okay. Yeah. Okay. Thank you again, Kennedy. Let's move on to Dr. Oyeduni Anigoro, who will also take us the same topic, because today's seminar is about multiple regression. So let us hear Madam Oyeduni's side of the story. So, Dr. Anigoro, you have the floor, ma'am.
And good evening, colleagues. My name is Oyeduni Anigoro from Lagos State University. I'm presenting on multiple regression. Multiple regression is an extension of simple linear regression.
Madam, how many of these seminars? Madam.
My name is Oyeduni Anigoro from Lagos State University. So, sir. Multiple regression tends to measure relationship between variables. It is used to predict the value of a variable based on the value of two or more other variables. And the variables referred to here are as two dependent variables, which is the predicted, and independent variable, the predictor. A brief history of multiple regression.
Tell us to move to slide 3, Madam. Madam, tell us to move to slide 3.
Slide 3. I'm on slide 3 now. A brief history of multiple regression. Sir Francis Galton began the study of multiple regression, which was improved upon by Carl Pearson. They were the first to apply this statistical tool to the study of human differences and inheritances of intelligence. Slide 4. Purpose of study. This is hypothetical. I want to use multiple regression to understand whether exam performance can be predicted based on revision time, test anxiety, lecture attendance, and gender.
Good.
The variable we want to predict is exam performance,
Sure.
while revision time, test anxiety, lecture attendance, and gender are the predictors.
Correct.
Slide 5. Now, assumptions for using multiple regression. One is normalcy of population. That is, the sample must be from a normal population. We have homogeneity of variance. That is, the variance of the score must not be too dispersed
Good.
from one another.
Excellent.
We have a random selection of variables. That is, all the respondents must have equal chance. Next slide, please. The mathematical model.
Good.
That's slide 5. The mathematical model representing multiple regression, where y equals to a plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4, and we can go on and on depending on the number of predictors that we have.
Excellent.
Where a is the constant and b1 to b4 are the beta weights.
Fantastic.
Y is predicted, while x1 to x4 are the predicted. Next slide, please.
Yes, ma'am.
When do we use multiple regression? When we want to make predictions or to forecast. When you have 3 or more measurable variables. We use multiple regression to understand the cause and effect in a relationship. It also helps us to predict trends and future values.
Correct.
For example, you want to know what will be the price of gold 6 months from now. Multiple regression can help us to achieve this.
Yeah. Why do you select gold? Do you like gold? Do you like gold so much? Okay. Go ahead. Go ahead, madam. Just joking. Yes, madam. Go ahead.
Yes, sir. Okay. How to use SPSS for this statistical tool? The first thing is to collect your data, then you export them to MS Excel to put them in tabular form. Then you copy it to SPSS. While it's on SPSS,
sorry, can I interrupt you? Sorry, madam. Madam, sorry to interrupt you. I know I should have asked this at the end, but I'm just curious to know, so I don't let it slip by me. Have you used multiple regression in class?
Yes, sir.
No, I'm asking her. You're not presenting. I'm asking her.
Okay.
Have you used multiple regression in class, madam?
Yes, I'm hearing you, sir.
I say, have you used multiple regression in class?
How do we use it?
Have you yourself, have you used multiple regression in class?
Yes, sir, I am.
Okay. Now, what's your step 2 on that slide? Your step 2 on that slide. What's the step 2 on that slide?
Step 1.
After collecting data. The collect data is the first one.
Then you put it on Excel.
Yeah, did you ever hold on. Let me just ask the class. Did you ever use Excel for this analysis?
No, sir.
Okay.
Oh, okay.
No, madam, I'm asking you yourself. Did you use Excel?
No, sir.
So how come? Maybe you just copy this one from somewhere and you just copy the wrong thing. Now, nothing wrong with using Excel, but I've told you what the challenges are. Who can tell me what the challenges are when you now put this thing in Excel? What will be the challenge? Anybody? Okay, we did not appreciate Excel well because of the difficulty. Just like Dr. Aino said, from Layo Aino, that you find that in entering the data, you just be going lengthwise like that, and you may not be able to get to see what the labels are at the end of the day. Anyway, that's just an aside. So, Madam Anigoro, you can keep going.
To SPSS. Can I continue, sir?
Yes, madam.
You click on Analyze, then go to Regression, then to Linear on the main menu. You now transfer the dependent variables into the dependent box and do the same for the independent variables. This will give us a, then you OK it, this will give us a linear regression.
Okay.
This is how the table will look like.
In which slide? Which slide, madam? How many times will we tell you about the slide number?
Slide 9, sir. Slide 9. Slide 9. Slide 9. That is how the SPSS table looks like after transferring the variables to the appropriate places. Then on slide 10, this is the result. This is the result we'll have. Now, the interpretation of the result is on slide 11. Slide 11. The model summary table presents the adjusted R-square value of 0.473, which implies that the four independent variables jointly account for about 47% variation on the dependent variable Y. And from the ANOVA table, F 4,52 is equal to 13.59, which is P less than 0.05. This implies that the model is statistically significant at 0.05. Therefore, the null hypothesis is rejected.
That's correct.
The coefficient table shows a negative relationship between x1 and y, and the relationship is statistically significant at p less than 0.05. Also, there exists a negative relationship between x2 and y, but the relationship is statistically not significant at p greater than 0.05. The same relationship exists between x3 and y. However, the result shows a positive relationship between x2 and y, and the relationship is statistically not significant at p greater than 0.05.
Okay.
Slide 12. In conclusion, we have the line of best fit,
Yeah, that's nice.
which is a straight line that best represents the data for the scatter plot.
Good.
That
Yes.
is my conclusion, sir.
Okay, that's very good. Thank you very much. Yeah, you can see the class applauding you. Very good, madam. Very good, madam. Very good, madam. So that's our third and last presentation, and we'd like to take some questions across the table. And please listen very carefully about the order, so that by the time I call you, you are not going to spend 1 hour waiting to ask a question. Francis, you are starting, followed by Johnson. So let's take those first two. Madam Moraka, there's some noise coming from your end. Some noise coming from your end.
It's raining, sir.
Okay, that's fine. Rain is good. It will allow you to sleep well. Francis, question.
Sir, in slide 2, the last 3 lines, it says the two variables are independent variable and independent variable. I'm not comfortable. Should that be independent variable? Actually not. So instead of saying independent variables, because as multiple regression, there should be many independent variables.
That is correct, Francis. I think it's an error on the slide. as multiple regression, it should be independent variables, meaning that you have so many predictors. That's very good. Johnson.
On slide 11.
Yeah, after Johnson, Mary and Stephen, please stand by. Yes, slide 11.
On slide 11 on the interpretation, while Dr. Kennedy was presenting, he said something about the R and adjusted R square, and he was able to interpret that the model was not a very good one. I want to ask Madam that with 7.3%, is the model a good one or not?
Very good question. Maybe, okay, she will answer it, although I have a quick answer for you. Thank you, Madam Mary, followed by Stephen.
Yes, sir.
Stephen, your question.
Hello, sir.
Stephen, your question. Okay, we'll take on Madam Fumilayo Aino and Iroko.
On slide 5.
Slide 5.
She said normalcy or population. Is it normalcy or normality? Or are they the same?
Oh, good question, Madam Aino. I'm proud of you. You are first class. Yeah, good. Iroko.
Slide 7.
Slide 7.
Slide 7 went to use multiple regression. The third bullet. Is it to understand cause and effect relationship or to check the main and interaction effect?
Well, okay. Bileyi followed by Larry.
Hello. On slide 5.
Yes.
On slide 5.
Okay.
Assumptions for using multiple regression.
Yes.
I don't know why you exclude number of cases because we were taught about 5 in the class for multiple regression.
Yes.
Normalcy, homogeneity, random selection, multicollinearity, and the number of cases, that is sample size.
That's
I
correct.
don't know whether that is not relevant.
Okay, thank you. Wonderful, well done. So back to Bileyi and Larry. Larry, your question?
Yes, sir.
Iroko, I think that's all. Madam Anigoro, you have the floor to answer the questions, the ones you can attempt to answer.
The assumptions for using multiple regression.
Yes, ma'am.
I said that the samples must be from a normal population.
Yes.
And that the variance of scores must not be too dispersed from one another.
No, you missed the point, madam.
These are the assumptions
No, you missed the point. You wrote normalcy or population, not normalcy. Normal. Can you correct it yourself? That's the one she's talking about. Normality or population, normality, not normalcy. Normality, that's all he's saying. And somebody is also asking you about sample size, which we discussed in class. We say N should be minimum 15 times the number of predictors. So you will miss that out. So please answer the other questions. Since you have some challenge with the lines breaking, no problem. We'll just have to let me attempt giving answers to some of the questions. I think one that Johnson raised has to do with the interpretation of this table, of the tables I read there. That adjusted R square value being 0.473. And in the case of Kennedy found that the F wasn't significant, which is quite fine. But in this case, the F is significant. And for the 7.3% contribution or explanation of the variation, also holds true for this particular model. So the critical thing to look at will be your ANOVA table. If it is significant, then the model is good. If it is not, then in the case of Kennedy, then you can come to the conclusion that Kennedy came to. So she's quite fine with this. F is significant at 0.05. So that makes the difference in there. So that I think will be more or less it for this session on multiple regression analysis. I've enjoyed every minute of the class, and we have all done well. We have 1, 2, 3, 4, 5, 6. We have 12 people, in class today. Great doctors, great doctors. So let me now bring the class to a close and wish you a very fine evening. I will be uploading the session maybe tonight or tomorrow. Taking on family days. Pardon?
Thank you, sir.
Thank you for being patient with us.
No, it's fine.
Thank you, sir.
God bless you all. By the way, by the way, I enjoyed that of Kennedy
you,
very
sir.
much. I enjoyed that of Madam Mani Aniworo also very much. I hope you enjoyed the presentations today.
Yes, sir.
They were very good, very good. Yeah, except that Helen disappeared from orbit.
No problem.
Yeah. That's it. Yes, which we don't have control over. But we just continue to try. We continue to do the best we can and improve our knowledge and skills. So, okay, class. Good night to all. It's 20 to 11 p.m. 20 to 11 p.m.
Nice, sir.
Yeah, we started at 9 o'clock. 20 to 11, which is quite good. Bye bye. God bless you all. Bye.
Nice, sir.
Good night.